Welcome to my channel. Today we look at another application of the cross product in determining area of the parallelogram. In the other video, we looked at how to find the area of a triangle using the cross product. So we begin with an example, and the example says that prove that the area of a parallelogram of sides alpha and beta is given by the magnitude of alpha cos beta. Now, just before we proceed, let me just remind you something, that if alpha is a vector and beta is a vector, then we say that their cross product, the magnitude of their cross product will be given by the magnitude of alpha times the magnitude of beta sine theta, where theta is the angle between alpha and beta. So this is the magnitude of alpha cross beta. And this one we want to show that this becomes the area of a parallelogram. So that is what we want to show in today's video. And then, of course, we will proceed and find area of parallelogram. So the question is, prove that the area of a parallelogram is given by this. So I've drawn a parallelogram here. And what we know that the area of a parallelogram is given by height times base. And of course, you know that a parallelogram is a four-sided figure, and the opposite sides are parallel and equal. So this side is parallel to this and equal, and also this side is parallel to this and equal. So for us to get the area, and then what we need is height times base. Height times base. That is how we get area of a parallelogram. And so we take the length of the base times our height. Now, this way I put the height, and this is the angle between this alpha and beta. So we know that we can use trigonometric ratio, that is sine theta is height over hypotenuse, opposite of hypotenuse, and our hypotenuse alpha. That means that H is alpha sine theta. H is alpha sine theta. And therefore, since area is given by H times the length of the base, but height is given by that, we can substitute this where there is height and find that area becomes, instead of height, we write the length. And remember this, you can have it as the length. So that is the length of this. The length of this is alpha, the length of alpha. Sine theta times the length of the base. So when I rearrange this, what I get is magnitude of alpha times magnitude of beta sine theta. And this is what we said is the definition of the magnitude of alpha cos beta. And so this is what is required. So we have shown that the area is given by the magnitude of alpha cos beta. So now let's look at an example of how to determine area of a parallelogram if you are given two sides. So the question is this: find the area of a parallelogram that is bounded by these two vectors, alpha and beta. So what we know that area will just be given by the modulus or the magnitude of alpha cos beta, and that's what we want to do. We just need to get alpha cos beta, and then after getting alpha cos beta, we get the magnitude. And so we proceed with our simple way of getting the magnitude of getting the products, the cross products, ijk and we write the coefficients of alpha 2, 4, 4, and the coefficients of beta -4, 4, 7, and then these two columns, add them here, the column of I and the column of J. And you notice that we have the three diagonals running from top left to bottom right. Multiply along these diagonals and add the result. So for instance, this will give us 28I, and this will give us -16J, and this other one will give us 8K. And then we also have these other diagonals in the red. They're running from top right to bottom left. We multiply along these diagonals and subtract the result. So for instance, this will be 14J, so subtracted 14J. And this one will be 16I, subtracted 16I. And this other one will be -16K. When I subtract -16K, what I get will be +16K. And then collecting like terms, 28I minus 16I gives me 12I. -16J minus 14J gives me -30J. And then this other one, 18K plus 16K gives me, is it 16? 16. So this one is supposed to be 34, not 24. So it's supposed to be 34, but let me just see. This one was, no, this was 8. This was 8K, not 18. This was 8K. This was 8K, not 18. I wrote 18 instead of 8. And this was -16J. And this was 28I. So 8K and 16K should be 24. Should be 24. So let me just erase this. Just erase this. So now we have the cross product alpha cross beta. What remains to do is to get their modulus or their magnitude. And you know that we'll be squaring 12 plus the square of 30 plus the square of 24. And this is what we get. Then the square root gives us the area. So this is the area of this parallelogram. So that is how we get area of a parallelogram. There are various methods of doing that, but we've chosen to use the knowledge of the cross product to do the same work.